Recording has started.
I realize that these are longer problems and many of you might not be done with them yet, but that's fine. Let's see if you're on the right track for what you have so far. Now, both of these systems are set up so that they would be fairly easy to solve with substitution. Both of them have a variable. There's just the y here and just the y there that we could solve for pretty simply. We wouldn't have to divide when we solve for it. But both of these systems are also set up to be easy to solve, to work with elimination or addition where we ended yesterday. So that's the way we're going to start this off today, is we're going to use addition method or elimination method to solve these two. So for the first one, remember we have to double check. We have x's, y's, equals, and constants. So we are set to, we can go ahead and do the addition method. Then we're just going to combine on the left side. We'll combine the 3x and the 2x. Make 5x. Positive 1y and negative 1y cancel out. The y's are gone. Equals, on the right side, 1 plus 9 is 10. So then we can divide by 5, get x equals 2. Now we still have to find y. I'm going to go back up to the top equation here. So 3x becomes 3 times 2 plus y equals 1. We combine what we can combine. 3 times 2 is 6. And now we're ready to solve. I'll subtract 6 from both sides. Y equals negative 5. So our solution here is x equals 2 when y equals negative 5. Second equation. Again, we have to check to make sure we're lined up. X's, y's, equals, and constants. We are lined up. So we're going to go ahead and do the addition method. So 2x and negative 2x cancel out. Gone. Adds up to 0x. 3y plus y. Remember, we think of that as a 1y. So 3 plus 1 is 4y. Equals, on the other side, 6 plus 10 is 16. Now we'll solve that for y by dividing by 4. Get y equals 4. Next, we have to find x. I'm going to go up to the top equation since it's all positive. 2x plus 3y becomes 3 times 4 equals 6. We combine what we can. The 3 times 4 becomes 12. So it's 2x plus 12 equals 6. We will subtract the 12. 2x equals negative 6. And divide by 2. X equals negative 3. So our solution here, we have x is negative 3 when y is 4. That's our ordered pair. Well, both of those systems were set up so that once they were lined up, one of the variables was eliminated when we added the equations. Not always the case. We can end up with a system like this. Let's do 3x minus 2y is 11. X plus 4y equals 13. As we look at this equation, this system of equations here, I'm going to label them A and B for now, again, for ease of reference. I see that they are lined up, x's, y's, equals, and constants. That part's good. But if I go to add these equations, nothing is going to be eliminated. We add them, I got 3x and x is 4x. Negative 2y and positive 4y is a positive 2y. 11 and 13 is 24. I did not get rid of any of my variables. That doesn't do us any good. So we don't want that. Sometimes we have to adjust one of our equations to force it to cancel out. What do I mean by that? Well, here we think in terms of least common denominator, least common multiple. For the x's, I could multiply the bottom one by a negative 3, I suppose, and they would cancel out. Then I would have 3x and negative 3x. For the y's, well, I've got a negative 2 and a positive 4. If I multiplied by a positive 2, this would become a negative 4, and then those would cancel out. So it's really a matter of personal preference, which variable you want to get rid of here, because it's going to be about the same amount of work. I am going to multiply equation A by a positive 2. The reason I'm doing that is that one allows me to multiply by a positive, so I'm not dealing with quite so many negatives. So when I do that, I'm going to get 2 times 3x is 6x. 2 times negative 2y is a negative 4y. Equals, and here's the part most people forget. Don't forget this. I have to multiply the other side by 2 as well. 2 times 11 is 22. This bottom equation is going to stay exactly the same. X plus 4y equals 13. Now we notice that if we add the equations, the y is going to disappear. So we add 6x plus x, that's 6x plus 1x makes 7x. Negative 4y plus positive 4y is 0y, so that cancels out. Equals 22 plus 13 is 35. I solve for x by dividing by 7. X equals 5. Now I need to find y. I can go back to one of these equations that I've modified, or I go back to the originals. It doesn't matter. I prefer to go back to an original if I can. Let's go back to this one here. So instead of x plus 4y, it's going to be 5 plus 4y equals 13. There's nothing to combine there, so I'll start to solve. I'm going to subtract the 5. 4y equals 8. Now I'll divide by 4. Y equals 2. So the solution we get there is x is 5 when y is 2. So we might look at something like this. When we look at this system of equations, we need to make sure things are lined up, and here they're obviously not. So that top equation has to be rearranged. The x needs to be over here. So to do that, I am going to subtract it from the right side to get rid of it on the right side, which will move it to the left side. I have to subtract it on the left side as well. So it's gone on the right side over there. Now, typically the way we would write this left side, we would write 5y minus 2x. But we want the x first. So 5y minus 2x is going to be written as 2x plus 5y. It means the same thing. On the right side, all we have left is the 1. So now our system of equations, the first equation is negative 2x plus 5y equals 1. That was from this equation. The bottom equation then is 2x minus 3y equals negative 3. Now they're lined up. X's, y's, equals, and constants. Once they're lined up, we check and we see that here the x variable will be eliminated when we add the equations. Negative 2x and positive 2x cancels out. It's 0x. 5x and negative 3x is 2x. 1 and negative 3 makes negative 2. Now we can solve, oops, that should be a y there, not an x. 5y and negative 3y make 2y. Now we can divide by 2 to solve for y. Y equals negative 1. Now we still need to find x. We can go back to any of these equations we have here to do it. I'm just going to go back to that top one. 5y becomes 5 times negative 1 equals 2x plus 1. I'll combine what I can here. 5 times negative 1 is a negative 5 equals 2x plus 1. Now I'll subtract 1 from both sides. Negative 6 equals 2x. And we solve for x by dividing by 2. We get negative 3 equals x. So our solution here, x is negative 3 when y is 1. So we might have something like 2x equals y minus 3. And 3x plus 2y equals 13. So our first job here is to get them lined up. The bottom equation it's x, y equals constants. The bottom equation is good to go. Top equation needs to be adjusted. I'm going to label them equations A and B again, just so I can refer to that top equation as equation A. In that equation A, y has to be moved over to the other side. So I'm going to subtract y. I now have 2x minus y equals negative 3. That is now properly lined up. So my equation A is 2x minus y equals negative 3. Equation B has not changed. 3x plus 2y equals 13. Now, as I'm looking at those equations, I see that nothing is going to be eliminated if I add the equations. If I look at the x's, I've got coefficients of 2 and 3. Their least common multiple, or least common denominator, if you prefer, would be 6. I'd have to multiply both equations to do that. As we look at y, that's a negative 1y and a positive 2y. That least common multiple would just be the 2. If I multiply this top equation by 2, that'll turn this into a negative 2y, and then it would be eliminated if we add the equations. So let's do that. That top equation, we multiply by 2. Remember, we have to multiply each digit or each piece of the equation. 2 times 2x is 4x. 2 times negative 1y is a negative 2y. Equals, we have to remember to multiply the other side as well. 2 times negative 3 is a negative 6. That's equation A modified. Equation B is just going to stay the same. 3x plus 2y equals 13. Now we see that if we add the equations, the y variable will be eliminated. So 4x plus 3x is 7x. Negative 2y plus positive 2y cancels out, equals negative 6 plus 13 is 7. Now we can solve for x by dividing by 7. X equals 1. Now I have to go back and find y. Well, let's use the bottom equation since there's negatives in equation A. So we'll use equation B here. And we're going to write that as 3x becomes 3 times 1 plus 2y equals 13. 3 times 1 is 3 plus 2y equals 13. We'll subtract the 3. 2y equals 10. And we'll divide by 2. Y equals 5. So this tells us that x equals 1 when y equals 5. I'm going to have you guys try one in your notes. So there's your equations. Solve that system of equations. I'll give you about 3 minutes here, then we'll go over. It looks like some of you might not be done yet, but let's see how it's going so far here. I labeled them equations A and B. Equation A is not in the right form. So the first thing we have to do is rearrange that. So we are going to subtract 2x to move it over to the other side. Again, that technically gives us 3y minus 2x, but we're going to rearrange that to be a negative 2x plus 3y. On the other side, all we have left is the 7. So our equations now become equation A, negative 2x plus 3y equals 7. Equation B is 2x plus 5y equals 1. They're in the right form now, and we do see that the x will be eliminated if we add the equations. Negative 2x and positive 2x cancel out. 3y and 5y makes 8y. 7 and 1 makes 8. We solve for y by dividing by 8 to get y equals 1. Then we go back to find x. I'm going to use the bottom equation since it's all positive. 2x plus 5y will become 5 times 1 equals 1. We combine what we can. 5 times 1 is 5. Now we solve. We'll subtract the 5. 2x is negative 4. Now we divide by 2. X equals negative 2. So that gives us x is negative 2 when y is 1. I'm going to have you solve this one in your notes quick. So we've got 2x plus 3y equals 11. Negative 4x plus 2y equals 2. I'll have you solve that one quick as well. I'll give you about 2 minutes on this one, and then we'll go over it. Okay, so let's take a look here. These are correctly, in the correct setup, x's, y's equals constants. So we don't have to worry about that. But we notice that the way they are, if we add the equations, nothing's going to be eliminated. But we see that for x, we've got a positive 2x and a negative 4x. If I multiply that top equation by 2, that'll give me a positive 4x, and then they'll cancel out. So we're going to multiply that top equation by 2. 2 times 2x is 4x. 2 times 3y is a positive 6y. Equals, again, we have to remember to multiply that other side. 2 times 11 is 22. The bottom equation, equation B, is going to stay the same. Negative 4x plus 2y equals 2. So now we can go ahead and add the equations. 4x and negative 4x cancel out. 6y and 2y make 8y equals 22 plus 2 is 24. So we eliminated the x variable this time. Now we can divide by 8 to solve for y. Y equals 3. And now we can go back to any of our equations, one of our modified ones or one of the originals, it doesn't matter. I'm going to go back to the original here. 2x plus 3y can become 2x plus 3 times 3 equals 11. I'm going to combine what I can combine. 3 times 3 is 9. So 2x plus 9 is 11. And now I'll solve it for x. Subtracting 9 gives us 2x equals 2. And dividing by 2 gives us x equals 1. So we have x is 1 when y is 3 is our solution. Now, in the last several examples, we've only had to multiply one equation. We don't always have that option. We might have something like this. 3x plus 2y equals 2. X plus 5y equals negative 6. Now again, I'm going to label these equations A and B just for quick reference. As I look at these, I see that they're lined up correctly. X's, Y's equals constant, so I don't have to worry about that. But nothing's going to cancel out. If I add the equations, nothing's going to be eliminated. So, if I look closer, look at each of them and think of common multiples. For x, I have coefficients of 3 and 2. That'd give me a common multiple of 6. For y, I have coefficients of 2 and 5. That would give me a common multiple of 10. So I could turn the x's both into 6's, or I can turn the y's both into 10's so that I can eliminate one. It really doesn't matter which. I'm going to choose to turn the x's into 6's because it's a little bit smaller number. But it really doesn't matter. It'll be the same amount of work no matter which one we did. So I'm going to multiply this top equation by 2. And the bottom equation, I'm actually going to multiply by a negative 3 instead of just 3. Remember, we need one of the x coefficients to be a positive 6 and the other one to be a negative 6 so that when we add them, they eliminate each other. They cancel out and we get 0x. So now let's go ahead and do the multiplication. 2 times 3x is 6x. 2 times 2y is a positive 4y equals 2 times 2 is 4. On bottom, negative 3 times 2x is a negative 6x. Negative 3 times 5y is a negative 15y equals negative 3 times negative 6 is a positive 18. Now, again, it's set up in the right order, and we see that the x, if we add the equations, the x will be eliminated. 6x plus negative 6x cancels out. 4y plus negative 15y is a negative 11y. 4 plus 18 is 22. So we've eliminated the x. Now we can solve for y. We'll divide by a negative 11 to get y equals negative 2. Doesn't matter which equation I go back to. I'm going to go back to equation A just because. So 3x plus 2y, 2y becomes 2 times negative 2 equals 2. Combining what we can here, 2 times negative 2 is a negative 4. 3x plus negative 4 equals 2. To solve it, to get rid of the negative 4, I'm going to add 4. I could have subtracted a negative 4, which would have been adding 4, same thing. So 3x equals 6. And I divide by 3, get x equals positive 2. So our solution here is when x is positive 2, y is negative 2. So sometimes both equations have to be multiplied to get us to a point where when we add the equations, something's going to be eliminated. So we're going to do here 2x plus 3y equals negative 3. And 5x plus 6y equals negative 9. I'm going to have you try that one in your notes. We'll go over it in about 2 minutes. Let's see how you're doing. I realize some of you might not be completely done here. Once again, we have them lined up correctly. X's, Y's, equals, and constants. So we don't have to rearrange the equation. But we do have nothing, if we add the equations, nothing's going to be eliminated right now. We could turn the x's both into 10s. So I'd be multiplying one by 5 and the other by 2. Or the y's could just be turned into 6s. We would only have to multiply the top equation to do that. I'm assuming that's probably what most of you did, was change the y's. So to prove that it's going to work out either way, I'm going to do the x's. It's a little bit more work, but I just want to show you that we will get the same result either way. So I'm going to multiply this top equation by 5. The bottom equation by not 2, but negative 2. So I get a negative 10x there. So the top equation here, 5 times 2x is 10x. 5 times 3y is a positive 15y. Equals 5 times negative 3 is a negative 15. On bottom, negative 2 times 5x is a negative 10x. Negative 2 times 6y is a negative 12y. Equals negative 2 times negative 9 is a positive 18. Now, when I add my equations, the x will be eliminated. 10x plus negative 10x is 0x. That cancels out. 15y plus negative 12y is a positive 3y. Negative 15 plus 18 is also a positive 3. We divide by 3 to get that y equals 1. Now we solve for x. Doesn't matter which equation we use. Let's just use the bottom one since it's right there. So 5x plus 6 instead of y, we're going to put in times 1 equals negative 9. So we can combine 6 times 1 is 6. So 5x plus 6 equals negative 9. We'll subtract 6 from both sides. 5x equals negative 15. And we'll divide by 5. X equals a negative 3. So x is negative 3 when y is 1. Okay, I've cut into your homework time a little bit, so let's give you your homework here. Homework out of the big book. It is page, where did my page go? There it is. 481 through 482. Exercise 17-3B, 7 through 27, the odd. And page 483 through 484. Exercise 17-4, 7 through 21, the odd. So we have only about 5 minutes left. If you would like to start working on those, I'll be on the network to answer your questions. Otherwise, that is all.